Good morning, class 10. Welcome all of you in mathematics period. Circle, the chapter I have already started, and there are two theorems. One theorem I have explained in the previous period. Today I am going to explain another theorem. This is the last theorem, only two theorems in this chapter. And after the theorem, you will solve the question 10.1 and 10.2. That's all in this chapter. Before starting the theorem, I would like to remind once again what are tangent. Tangent is a line which intersects the circle at only one point. If I ask you if a line intersects the circle at 2 points, so what is the name of this special line? This is called secant. So you understand difference between tangent and secant? Sorry. Now you see, if I ask you how many tangents can you draw from a point inside the circle, what will be your answer? No tangent can be drawn, because suppose here is a point, so if you draw a line through this point, so this line will intersect the circle at 2 points. So tangent is that line which touches the circle at only 1 point. And then you come to this theorem. Theorem is, if tangents are drawn from any external point to a circle, then length of tangents are equal. How can you prove? In geometry, you know, theorems are in the theorems, facts are proved without measurement, with the help of logic, with the help of axioms, with the help of postulates, with the help of universal facts. So this theorem, how can you prove? So here you see the figure. This is a circle and center is O, and P is the external point outside the circle. How many tangents can you draw from this external point? We can draw maximum 2 tangents. So these are the tangents PA and PB intersecting the circle at point A and B. So now you have to prove PA is equal to PB. This is the theorem. You know very well, in the theorem, most of the theorems, we need some extra construction, and then we try to reach to the conclusion. Construction is, we have joined PA, OA and OB. No, PA and PB is already given. We have joined OA, OB and OP. By joining, you see in the proof, we have got 2 triangles. Triangle PAO and PBO, 2 triangles. In these 2 triangles, we are trying to prove congruent, and then by simplicity, we will get the result. So in these 2 triangles, congruency theorem, how many theorems you know? Triple H, SAS, RHS and ASE. These are 4 theorems of congruency. And now we have to see which theorem is applied here to prove these 2 triangles congruent. Now we see in these 2 triangles proof. OA is equal to OB. Why? Because they are radii of the same circle. In a circle, all the radii are equal. So OA and OB are the radii, and therefore they will be equal. Number 2, OP is equal to OP, common. This is common side in both the triangles. And these 2 angles are equal because they are 90 degrees. If question arises in your mind, sir, how can we say these 2 are 90 degrees? Theorem number 1. Radius is perpendicular to the tangent at point of contact. So by theorem number 1, these angles are 90 degree and therefore they are equal. So what do you see? In these two triangles we see two sides and one angle, that is right angle. This is not SAS theorem because SAS में ये दोनों साइड और ये बीच का एंगल इंक्लूडेड एंगल होता है. SAS theorem क्या है? If two sides and included angle, included means the angle formed by these two equal sides. Therefore, SAS theorem is not applied here. We are using RHS theorem. What is RHS theorem? In two right triangles, if one side and if two sides are equal, and one angle is right angle. So by RHS these are congruent, and therefore by simplicity PA is equal to BP, and this was to be proved. यही प्रूव करना. So this is very important theorem. What is the theorem? I would like to repeat. This is the statement: tangents drawn to a circle from external point are equal. This is the figure according to the theorem. This is a circle, O is the center, and P is any exterior point for the circle. And from this exterior point, as I have told you, we can draw maximum 2 tangents. We cannot draw more than 2 tangents because if you try to draw, so this will either intersect the circle at 2 points or it will pass out of the circle. So PA is equal to PB. You have to prove PA is equal to PB. So given circle whose center is O, P is external point, P and PB are tangent, prove that PA is equal to PB. Construction, we have joined OA, OP, OB. Now you see the proof. By joining, we are getting 2 triangles, and these 2 triangles are right angles because this is 90 degree, theorem number 2, the radius is perpendicular to the tangent at point of contact. So OA is equal to OB, radius, OP is equal to OP, common, and angle A is equal to angle B, right angle by theorem number 1, and therefore they are congruent by RHS. Here you should be very careful. You will not write SAS. SAS means यहाँ भी हो रहा है 2 sides and 1 angle, but it is not included angle. So we cannot say these are congruent by SAS. These are congruent, but by RHS theorem. And if theorems are congruent, triangles are congruent, corresponding parts of congruent triangles are equal, you know very well. By CPCT, PA is equal to PB. This is the theorem. So by using this theorem and the previous theorem क्या था? In a circle, the radius is perpendicular to the tangent. In a circle, the radius is perpendicular to the tangent at point of contact. These are the points of contact. So this is 90 degree. I have explained, and today I have explained the theorem number 2. Tangents drawn to a circle from external point are equal. So very, very simple theorem. And by using these 2 theorems, you will try to solve 10.1 and 10.2. So thank you and have a nice day.